Why the brain keeps firing. Why the brain keeps firing after the heart stops. The heart stops. The EKG goes flat. By every traditional definition, the person is dead. But in the brain, something else is happening. Something scientists didn't fully document until 2023, and still don't completely understand. What we thought we knew. For most of medical history, death was understood as a cascade. Heart stops, blood stops moving, brain loses oxygen, brain shuts down. The brain was seen as passive in this sequence. The heart fails, the brain suffers the consequence. Simple. That model is not wrong, exactly, but it's incomplete. The brain, it turns out, doesn't just receive the information that death has occurred, it responds to it. The 2023 Michigan study. In 2023, researchers at the University of Michigan published findings from a study that monitored the brain activity of 4 dying cardiac patients with continuous EEG. When the ventilators were removed and the heart stopped, something unexpected happened in all 4 patients. Within 30 to 60 seconds of cardiac arrest, brain activity surged, specifically gamma wave activity, the highest frequency brain waves associated with conscious processing, attention, and sensory integration, spiked dramatically. This wasn't a gentle fade, it was a surge. The kind of gamma activity recorded in those final seconds was comparable to, and in some cases exceeded, the brain activity measured when the patients were fully awake and conscious before the procedure. This wasn't the first time this had been documented. A 2013 rat study at the same university showed an identical pattern. Rats showed a 30-second surge of coordinated brain activity immediately after cardiac arrest. The human study confirmed the same mechanism exists in us. What it might mean? The researchers are careful. Science is careful. Correlation is not explanation. But there are 2 leading interpretations of what causes the gamma surge. The first is purely mechanical. When oxygen deprivation begins, certain neurons become hyperexcitable. They're not trying to do anything. They're misfiring as their energy supply fails, the way a fluorescent light flickers rapidly before burning out. The second is more provocative. Gamma waves in a living, awake brain are specifically associated with binding, the neurological process by which the brain integrates sensory information into a unified conscious experience. When you see, hear, and feel something simultaneously and experience it as a single coherent moment, that's gamma binding. If the same gamma binding process is firing in the seconds after cardiac arrest, the question researchers now openly pose is this. Is the dying brain generating a final, intensely integrated conscious experience? Nobody knows. The data cannot answer that question yet, but it cannot rule it out either. The near-death experience connection. This is where the science becomes complicated. Near-death experiences, the tunnel, the light, the life review, the sensation of leaving the body, have been reported across cultures for centuries. They were largely dismissed by mainstream medicine as hallucination, oxygen deprivation, or confabulation. The gamma surge data doesn't prove near-death experiences are real perceptions, but it does provide, for the first time, a plausible neurological mechanism for why they feel so vivid and real to the people who report them. Cardiac arrest survivors who report near-death experiences describe their memories as more vivid than any normal dream, often more vivid than regular memory. That's consistent with what gamma binding does. It produces high-definition, integrated experience. The leading neuroscientist in this space, Dr. Jimo Borzigan at Michigan, describes the surge as the brain's final processing event. Whether that event involves anything experienced is still unknown. What is known, the brain is not passive in death. It's doing something specific, something documented, repeatable, and measurable. The implications. There are 2 practical implications of this research that rarely get discussed. The first is clinical. If the brain is generating significant activity for 30 to 60 seconds after cardiac arrest, the definition of irreversible death becomes more complicated. Organ donation protocols, legal death declarations, and resuscitation timing are all built on assumptions about brain function that this research is beginning to challenge. The second is personal. If the final seconds of life involve a surge of integrated conscious processing, then death is not, at least neurologically, an instant switch. It's more like a door that takes a moment to close. What happens on the other side of that door, science cannot say. But the door itself is more complex than anyone knew. That's not comfort. It's not horror either. It's just more true than what most of us were told.